Hey guys, so right now what we're going to be looking at today is transformations of quadratics. So this is where we are going to move the quadratic back and forth on the graph and kind of see what changes in the equation create changes on the graph. And this is a little different than I've done it in the past. So we're going to see how it kind of works out. What I'm going to do is I'm just going to give you the problems and we're going to discuss and talk about how we can solve them. Okay. The first thing I do want to remind you guys of, and I'm going to go up here to the top and I'm going to write down the equation. So the standard form of a quadratic equation is y equals ax squared plus bx plus c. Okay, where A, B, and C are numbers. And back when we did some properties and some, attributes of quadratics, we actually did talk about kind of what they look like and how it changes stuff. So that was 513. So back here on 513, we talked a little bit about the A value and some stuff like that. So I want to go back to this A value. And when the A is greater than 0, it's positive and it opens up. And when the A value is negative, it opens down. So we discussed that very briefly, and some of that is going to be applicable here. So what I want to talk to you about is the A value. The A value is kind of really important. So on the A value, if it's positive or minus, that tells you if it opens up or down, okay? The other thing is if it is a whole number, okay, so if it is a number greater than 1, okay, that actually makes it narrower. It actually makes it narrower, okay? And if it's a number, okay, between 0 and 1, so it is a fraction between 0 and 1, it actually makes it wider, which is a little bit opposite of what you would think. The beauty is we have the calculators and we can always test it in there. The other thing I want to remind you guys, and just like in old school, just like in our y equals mx plus b, is c is your y-intercept. So that is where it crosses the y-axis, all right? And as another reminder about quadratics, okay, the solutions are where it crosses the x-axis. We also call that roots and zeros. This is the key because we're going to talk about that. Okay, we're going to talk about that. So a lot of information right there at the beginning. I just want to review with y'all. So now let's go to the equation. Let's just start applying what we've already been learning over these last several weeks or months. The equation of y equals 3x squared minus 8 needs to be translated 17 units up, which is vertically shifted up. We're moving it up. Which equation describes the graph after it has undergone this translation? So we need to know what we're doing here. So we're moving it up. That's a plus or a negative. It is a plus 17. And it only affects the y-intercept. So negative 8 plus 17 is a positive 9. So the rest of the equation is going to stay the same. And then you're going to change the y-intercept to a plus 9. That's what you're going to need to do. Another option you can do if you're not sure is you can go on ahead and put the original equation in the calculator. So you can put your 3x squared in the calculator minus 8, correct? Okay. And you can graph it. And then you could actually just count up 17 units and see where it ends up. Okay, that's another option for you. Or you could plug in all these answer options and see. All right, I think the important thing is to note that it just affects the y-intercept. Number 2, given y equals negative x squared, if the function is shifted up 5 units, which equation describes the new function? So we're shifting it up 5, which is a plus 5, and that's just going to affect the y-intercept, the number by itself. So nothing happens to our a value, and that would just be c. It only affects the c value, only affects C value. Okay? Next, number 3. The relationship between the area of a square and the lengths of its sides is represented by the equation a equals s squared. The area of each triangle formed by a diagonal of the square is represented, lots of words, by the equation a equals 1/2 s squared. Describe how the graph of the function for the area of a triangle differs from the graph of the function for the area of the square. So you have the area, the lengths of the sides, right? And the area of the diagonal, right? So what we're going to do is we're just going to simply graph them and see what the difference is. Ready? So I'm going to go to y equals, I'm going to clear whatever's in there. And my first one, remember, you always use x as your thing. So it's x squared. Then you're going to go down and you're going to enter 1/2 x squared and see what the changes are. So what do we do to look at the graph? We hit graph. So there's our first one. There's our second one. It's real easy to see. What did it do? It got wider. Okay, it got wider. So as I told y'all earlier, is the key is this 1 versus this 1/2. If it's a fraction, it gets wider. Okay. Okay. Let's move up to our next one. Now, I automatically look at this and I see graphs and I think calculator. I'm going to go to the calculator. So let's read what it says. It says the box contains the graph of the equation y equals x squared minus 8. What would the graph look like if the equation were changed to y equals 1/4 x squared minus 8? So the first thing I notice, though, is I go to that y-intercept always, and it's a -8. So the first thing I'm going to look for is C and D are out because their y-intercepts are not -8. Okay, and I like to write that on the notes so I have a reasoning behind it. Okay, so I'm looking at the top two. Now I see that the number in front of x squared, and I'm going to change colors here, is a 1 on this one and a 1/4 on this one. So I know that it's actually going to a fraction. And I know the behavior there, but let's say we're not sure. Let's say we're not sure and we didn't read the numbers above. That's okay because you have a calculator. You just go put both equations in the calculator and check it. It is there. It is a tool. Please use it. So you have x squared minus 8. And then my next one would be 1/4. So I'm going to clear whatever's in there because the calculator doesn't like to clear it. It types over it. 1/4 x squared minus 8. And I'm going to graph both of them. There's my first one. There's my second one. It got wider. So I know that over here, my answer option is clearly going to be the A value. So again, as a note to yourself, and I didn't write this in the plug both in the calculator and y equals, and then look at the graph. Okay, plug both into y equals and look at the graph. Okay. And that was also the same thing on number 3. So I'm going to go add that in. Look at graphs on calculator. Sorry about that. All right. I even had it written on my notes and forgot. Number 5, the graph of y equals x squared is to be translated left 2 units and up 5 units. Write an equation to represent the image of the graph after the translation. Okay, so these are some different formats on A and B. So this is what I'm going to recommend to you, and then I will kind of explain to you the math behind it. Go to the calculator. That's what it's there for. It is a tool. Use it. Okay. So I'm going to type in the original equation, which is, excuse me, I'm going to clear what's in here, and I'm going to type in x squared. And then for my next equation, I'm going to type in each answer option and see what it does. So I'm going to do open parentheses, x minus 2, close parentheses, squared, and then plus 5. So I know, okay, I know right here, and this is something I didn't say, is that it's going to go left 2, and then it's going to go up 5. So I'm looking for that movement in the picture. I'm looking for that movement in the picture. So I'm going to hit graph. There's my original, and this one went right and up. So it went right 2 and up. So this would not be it. So this one moved right. Okay. Let's see what B did. So we'll go to B. We'll go to y equals. I'm going to go type over, and I'm going to change this to a +2. I'm going to hit graph, and it goes left and up. So that one is going to be the answer. You can go on ahead and put in the other answer options to see the behavior, but I am going to take this second to explain to you a little bit about the behavior. So what happens here is when you see these parentheses, so I'm going to come down here and I'm going to write a sample equation. And I'm just going to say that this is a random k, okay? So what happens when you see the equation written like this is that this number is telling you the shift left and right, if it shifts left or right. And it's actually the opposite of what you think. Right is a negative and left is a positive. So left is actually a plus right here. There's your left shift, okay? And then again, the last number is still going to affect your shift up and down, okay? Any questions there? So now let's go down to number 6. So again, this is another one that's dealing with the shifting left and right. Compared to its parent function of f of x equals x squared, what effect will we see in the graph of f of x of 2? And again, plug it in the calculator and look at the graph. So I'm going to take both of them and plug them in the calculator. I'm going to go to y equals. I'm going to clear what is in there because I don't want anything in there changing and typing wrong. So I have x squared, and I'm changing that x to x plus 2 squared. So this one's a little different. It's telling me to plug all this information in for my x value. So we're going back to some old logic and some old math that we've used, okay? So I'm going to plug this equation in. Now I'm going to look at the graphs. There's my first equation, and there's my second. So it shifted it left too, right? It translated it. So it moved the exact same thing to the left. The other way I can tell is that this value, it only affects the x. And since it's a positive, it actually moves the opposite direction. So it means it goes left because of the actual formula, okay? So a positive means it goes left, and a minus means it goes right because we're just affecting that x value. Last example, I believe, is number 7. The graph of y equals x squared plus 4 is shown below. What graph would best represent the graph of this parabola if it is translated down 6 units? So that's a -6 on the c value or the y-intercept, okay? So I'm just going to do -6, and that would put me at -2. Okay. The other way you could do that is actually count it. So here's my y-intercept down, down 1, 2, 3, 4, 5, 6, puts me at 2, -2. Oh my goodness, this thing drives me insane sometimes. -2. Okay. So which one does that? Not that. Number C. That's it. The other thing you can do is plug both equations in the calculator to see. But to me, that's easy. It's just affecting the C value. When you're shifting up and down, you're only affecting where it crosses the y-axis. You're only moving it up and down, okay? That's it. And when you're translating, just to follow up, when you're translating, it's the same thing in a different place. So when you translate, it's the same thing in a different place.